Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to the final video tutorial for the assembly assignment using Autodesk Inventor. In this video, I will show you how to do the assembly assignment. Before you start your assignment, you should already have draw the individual component of the assignment. There are 7 items in total, and before you proceed, please ensure that the name of each of this file is not changed before and after you do the assembly. If you change the file name after the assembly, then you cannot reopen the assembly file correctly. So please ensure that the file name for each of the files, each of the individual component is fixed and do not change after you done the assembly. Once you have done this, so let's open Inventor and start the assembly. Similar to doing standard part, click File and click New, and then in this, rather than select standard part, go for Assembly and select Standard and select Create. Now we come to the interface for the assembly work, and then on the left hand side, click this drop down button and select the function Place. Go back to the folder where you kept all of the individual files and select the part 1 vice body and select open. So you can see using the scroll to zoom out and place this individual item in the file. Right click, select OK. Select view, select visual style and select shaded with edges. And then right click on this component and select grounded, so that this component will not move around when we put in other individual component. And then go back to assemble, select place and select the function place, or you can simply select or click place over here, and then start with the vice jaw for our second component and select open and select place it on the screen. And then the software still asks you, do you need additional component? At this point, right click and select OK. So when you come to here, we want to make sure that these two individual components are merged in a proper way. So using the function constraint, select constraint, and this is the function that we are going to use to make sure that both of these components are placed well within each other. And please focus on the function of solution. You have mate and you have flush. You can see the differences between mate is it is opposite, and for flush it is for side by side to each other. Select the function mate, and then using this cube over here, go to the bottom and select this surface, and then go back to the original view and select this area. So when you click, you can hear a sound, and you can see suddenly this part is now moved on top of this component, and then select applied. Select flush and then select this area and the area, this one, and select applied. Now we want to check whether or not the component has been transferred accurately. So far it is good, but you can see that this vice jaw can move uninterrupted at all of these axes. So we need to put a constraint, whereas the vice jaw only move on a specific distance. Go back to constraint and then go back to mate, select this area and then this area. You can see now it is joined closely, and then using this function, click over here and then you need to put maximum. In this case, let's try for 35 and select applied. So you can see it can only transfer up until over here. It cannot go further than 35. But since we didn't set the minimum, the vice jaw can still move to the other side. So go back to the option that we did, which is mate. Right click and select edit, and then enable minimum. Select OK. Now you can see that this vice jaw only can move on this specific distance. The next step is to place the clamping plates. Select open, and we need 4 of this component. Before you place the component, make sure it is on the right position that you want. Right click and then rotate Z. Okay, we need 4 of this. Right click and select Y, if I'm not mistaken. Okay, 2 of this. Right click and select OK. So these 2 parts will be placed over here, and the other 2 will be on this surface. So select constraint, select mate, and select this area, and then select over here this surface, and then select applied, select flush this area and the top area, select apply, and still using flush this area and this area. You can see that the wooden component now placed not just nicely on top of the surface that we want. And let's proceed with the other component, and this one, repeat the process. The first one is to use mate, select apply, and then followed by flush. Select this surface and this surface, and then select apply, select this surface and this surface as well, and then select apply. So let's repeat for the other 2 component. Go behind the other way, and then select the surface using mate, and then select over here, and then select flush. Sorry, go back to mate. You have to click apply first, and then you select flush, select apply, and this one wait here, select apply. So let's do the last one. Mate, and select this surface, select apply, select flush this surface, select apply, and then select apply. Alright, and then remove the window, and you can see that the movement distance of this vice jaw is still logic. It does not interfere, even though there is a wooden component on top of them. So let's proceed with another component. We proceed with the part number 7, which is jaw screw. Select open, and then this one I want to rotate it first, so that the small part is facing into the component. So place it over there, right click and select OK. So now, using the function constraint, select for mate and select this surface, this surface, and then select right. You want to select the surface inside of this. So basically it is on the inside. It can only be seen from this angle, and select this one. So you can see the vice jaw is now placed onto the right slot, but there is still the position is still not correct. And then select constraint, and then select solution, select on this dotted line, and then on this green line. Okay, now this component has been placed accurately in the slot required, and then select apply. You can see now the components are working as intended. You can also move the jaw screw without the jaw screw interfering with other component. So let's move to the bottom. Select right, go to the bottom. Now we want to place another component at the bottom. It is called base plate, and we need 2 of these. Rotate by X. So let's try to rotate it first to check whether the position of the circle is correct. Okay. So this one is supposed to be turned around. So select the function free rotate, and then we want to move it 80 degrees, and select OK. Now using the function constraint, select mate as usual. Select this area over here, and select the surface. Select flush. You have to click apply first, only then you proceed with the function flush. Select apply, and this area to this one. Select apply. So start again, mate this area, and at the bottom select apply, select flush, select apply, and this area to this one, select apply. Okay, and then using the function view, visual style, select shaded with hidden edges. Make sure that the dotted line of the wooden component is aligned with the dotted line within the base plate. Within the vice body and also the base plate, the dotted line is aligned. This is to ensure that when you put in the screw, it will not interfere with another component. So go back to visual style and then select shaded with edges. Okay, go back to assemble, place, and then select this screw bar. Select open, and then rotate by Y axis, and select OK. So we need to place another 2 component over here, which is the bar globes. Select open, and one over here, and the other is on this side. Select OK. So this one also should be the other way around. Okay, so this one should be over here, and this one should be over here. So select constraint, mate, and select the length of the circle inside the axis, and then select this axis, select apply, and then go for flush. So this area and this area, so select apply. So proceed on the other end. Select the axis and this axis, select apply, and then select flush this area and also this area, and select apply, select OK. So now we want to place this, what we call screw bar, inside of this jaw screw. There is a slot over there, and it's supposed to go inside. So let's rotate the item first. Okay, it was a glitch just now. So I'm not sure why it doesn't follow, but I suppose once we put a constraint made, the bar globe should follow the position of the end of the jaw screw. Okay, now function constraint, select this one, select the axis, and select this axis over here, and select applied. So before that, we need to create another plane from this point and to the bottom. You can see there is a plane existed in the center of these two ends. This is to ensure that the component does not move around. You can see that it can still move inside and outside. So we need to put another constraint to ensure that it can only move on or it is fixed on a certain length only. So go to assemble, constraint, solution, go for mate, and select this plane and select this axis and select apply. Okay. So now the thing is already in place, and you can see that it will not move outside of the designated area. So I believe we have done most of the major component, and according to the drawing that I share in the class, students are still required to include the screw. You can see that there are 3 types of screw in this drawing, and to place the screw, you can use the database inside of the inventor. Use the place from content center, the function, and then inside of Autodesk Inventor, they already have a few options. I think too many options that you can use, and I would suggest you use AS1427. Double click and click on the screen. Wait for it to load it up. Select the trade description of M6. This is according to the question given, M6 over here, and you can see the length is 16. So nominal length is 16, or you can choose the closest length that you prefer. Select apply, and you can see now this is the screw that we are going to place. Rotate by Z. Okay, this one, and select OK. I'm just going to show you one example, and I hope the student can do the rest, especially on the screw. So we want to put the screw into the hole located over here. So select constraint, select mate, and select this axis and also this axis over here, and select applied, select flush, and this area and this wooden component. You can see that there is some mismatch of the color between the screw and also the screw and with the wood. This is because the size of the screw is a little bit bigger compared to the hole that has been created. So please choose the correct diameter of the screw. It is already indicated in the drawing. So using the function content center, you have to search what is the suitable screw that can be placed into the component. I believe this should be a good assignment for the student to try and explore. If you're having trouble to find the screw required or the screw compatible with the drawing, you can always draw your component individually. You do it yourself manually, but it is better if you can simply use the source or the content already available in the Autodesk Inventor. So go back to the isometric view, and then also in this assignment I would like to share with you how to assign materials. So this is the function material, the circle with black and white, and we want to assign wood material to the wood component. So let's find wood. Okay, let's go with oak. Okay, oak. Assign to selection. Okay, so just select the thing that you want and then right click and then assign to selection. And then the steel, previously I think I used steel. Let's say for the sake of example, let's use carbon steel. Select the material, right click and assign to selection. So when you assign a material to your component, you can see that the color or the appearance of the individual component will also change as well. So I hope this one cover the basic tutorial for the assembly assignment. Students just need to explore how to select and use and also to assemble the proper screw. So I hope all of you can learn how to do the assembly, because this is one of the example that we will use for the midterm soon. So I wish you all the best and thank you very much.